So EMIT is going to be looking at the arid land regions of planet Earth and understanding the mineral composition of those regions. In these arid land regions, under conditions of high wind, mineral dust is emitted or launched into the atmosphere and can travel thousands of miles, where it interacts throughout the Earth system. In our case, we're going to study how that mineral dust heats or cools planet Earth. Currently, we aren't sure whether mineral dust heats the planet or cools the planet in the lower atmosphere. Some minerals are dark, maybe more red. They would absorb solar energy and they could be heating elements. In other cases, minerals are bright white, like kaolinite or carbonate, and they could reflect sunlight back into space and cool the atmosphere. So this is a unique type of instrument invented at JPL, and what's special about it, it collects an image, but for every point of that image, it collects a full spectrum, a lot of wavelengths. So we can actually understand the chemistry of what we're observing in the atmosphere and in the surface and make these quantitative measurements in the case of EMIT about what minerals are present there based on their spectral signatures.
We're going to be focusing on the arid regions of the planet, and it's not an insignificant part of the planet is arid. You can just think of the Sahara. The whole of North Africa is, much of it is actually a really good desert dust source. But there's other regions as well, moving across the Middle East into Asia, Central Asia and East Asia, as well as in the Western United States. You can also think of South America and South Africa have desert dust sources. Basically, the only way to sample across all of these deserts is to use remote sensing. And so this experiment is so important for us to understand what's going on at the surface of the Earth in terms of the mineralogy and the composition.
We're going to launch on a SpaceX rocket that will go to the International Space Station. There's a Dragon vehicle that contains EMIT in its trunk, and the robotic space station arm will pluck EMIT out of the trunk and then install it in its place on the space station. EMIT is an imaging spectrometer, which means, well, it combines two words, imaging and spectrometer. So the spectrometer part means that it measures light in many different wavelengths of the electromagnetic spectrum. Our eyes see 3 wavelengths, red, green, and blue, but EMIT sees in hundreds of wavelengths out into the infrared. The imaging part means that we acquire these data at every point within an image. So you can think of it like a camera, except instead of just seeing red, green, and blue, our camera sees throughout the electromagnetic spectrum.